Okay, in problem 16 here, we just continue through the types of calculations I'm going to expect to be able to do with hydrogen and OH minus concentrations. So this is given one, what is the other, right? So we're going to use this relationship that's always true, H plus concentration times OH minus is 1 times 1. So this, we're going to plug in this case, we know for hydrogen it is 3.50 times 10 to the minus fourth, and multiply that by the OH minus must equal 1 times 10 to the minus 14th. And you're just going to do the arithmetic here. So you divide both sides by the one you know, this one. And so this side over here becomes 3.50 times 10 to the minus fourth. Cancels that. And then you do the arithmetic and you come up with your answer, which is this one in this case. And again, it's got to be, because we have a high hydrogen ion concentration, we have to have a low OH minus concentration. Now, moving on to problem 17, again, another type of calculation. I give you an acid concentration, and I need to know what the pOH is. So the first thing you want to do is look at the acid, and in this case, you hopefully recognize HClO4 as one of the 6 strong acids. And when we have a strong acid, that means the concentration of that acid in the bottle is completely ionized, so it's the concentration of the H plus. So we just take the minus log of that hydrogen ion concentration, and if you do that in this case, you calculate what the pH is. So when I do that calculation, my pH is 2.22, and pH plus pOH is equal to 14 because of the ionization constant of water. So I'm going to take pOH is equal to 14 minus the pH. So in this case, it is 14 minus 2.22, which is about equal to 11.8 or 11.78. Or that's the right answer for that one. Now we finally get into an ice calculation. Now, I like to put this problem on here because it asks you about HClO. And I put that right after the HClO4 problem. HClO4 is a strong acid, but this is a weak acid. That's why we're given the Ka. You're given the Ka, and so it becomes an ice problem. And we're going to simply write down what we know. So our starting concentration here, it tells us of the HClO solution is going to be initially 0.265 molar. And that means this is 0 and this is 0, and that's approximately 0, but we always do that assumption. It's really 0. And so we're going to lose this, so this is going to become a minus X, and we're going to gain H plus, we're going to gain ClO minus, and so this ends up being 0.265 minus X, and this is going to be X, and that's going to be X, and so our equilibrium is going to be 2.9 times 10 to the minus 8 is equal to our X squared over 0.265 minus X. Now, in this case, we have a very small ionization constant, so we can do the X is equal to small, and this simply becomes, we move 0.265 over here, multiply it by 2.9 times 10 to the minus 8, take the square root of that whole thing, and we're equal to X. Now when I do that, I get X is equal to 8, what I get, 8.76 times 10 to the minus 5th, and that's very close to that one, and so that's our answer, because it asks for what is the concentration of H plus. Could ask for the pH. I just take one more step.